Hey there, fourth grade. This is Mr. Campbell. Today we're going to be starting on page 81. This is going to be lesson 3.1, multiply by multiples of 10, 100, and 1000. At the end of this lesson, we want you to be able to say, I can find the products of multiples of 10, 100, and 1000 using mental math and place value strategies. All right. Now, one of the things that's kind of interesting about this strategy is there some shortcuts that we can do. And we don't want to just teach you shortcuts. We also want to make sure that we're teaching you why those shortcuts work, what they even are. So let's take a quick look over here. So they're asking us to solve some problems. 3 times 4, 3 times 40, 3 times 400, and 3 times 4,000. And these are called multiples of 10, 100, and 1,000. And the reason for that is when we multiply, so this is by 1, this is by tens, and that's because 40 is tens, right? 400 is hundreds, and 4,000 is thousands. And the special part of this is that there are zeros in all the other place values. And so here's why this becomes really kind of an easy shortcut if we can understand the math behind it. Well, let's start with 3 times 4. All right, so 3 times 4. 3 times 4 is going to give me 12. All right, so far, hopefully you're like, oh yeah, I knew 3 times 4, that was 12. Well, now I want to figure out what's 3 times 40. So 3 times 40. So when I do this, what I need to do is I need to multiply my ones place first and then my tens place. So 3 times 0 is 0. And then 3 times 4 is 12. So my answer is 120, which is interesting. And the reason that I wrote it like this is so that we can see our place value. So this is my ones place and this is my ones place. So maybe this would be a better way for me to also write it, right? Is 120. Okay. So I'm just going to draw my arrows to keep that straight for us a little bit. All right. So we've got 12, 120. Well, now I want to do 3 times 400. So 3 times 400. And so 3 times 0 is 0. And then my tens place, 3 times 0 is 0. And then in my hundreds place, 3 times 4 is 12. So my answer is 1,200. So let me go ahead and move this over. So I had 0, 0, 1, 2. I'm seeing some patterns here. Maybe you're seeing them too. Let's do our last one, thousands. So 3 times 4,000. 3 times 0, that's in my ones place, is going to give me a 0. 3 times 0, that's in my tens place, is going to give me a 0. 3 times 0 in my hundreds place is going to give me a 0. And then 3 times 4 is 12. Oops, I put the comma in the wrong place. I'm sorry. So my answer here would be 12,000. Oh, okay. So 12,000. What do you notice is happening? Well, I had 12, 120, 1,200, 12,000. They just keep adding another 0 every time. My 12 stayed the same. It just moves over a place value every time we add zeros. And here's the big kicker. You ready for this? Here it is. There were 2 zeros over here. And what's in my answer? 2 zeros. There were 3 zeros over here. And in my answer, 3 zeros. This is called multiples of 10. Because when we have multiples of 10, however many zeros, as long as they're all zeros over here, I can multiply this first part and then put those zeros at the end. And that's what we're going to take a look at. So let's go ahead and turn to page 82 and check out the example we've got. So here we are on page 82. And if you're not there, grab your pencil, pause the video, and get to page 82 before I get going on this, because I want you to be following along with me. All right. Now I'm going to go ahead and zoom in a little bit just so it's a little bit clearer, hopefully on your screen. All right. So it says, calculate 3 times 50, 3 times 500, and 3 times 5,000 using basic multiplication facts and properties of operations. So this says the associative property of multiplication tells us that we can change the grouping of the factors and the product stays the same. All that means is that we can move some of these numbers around a little bit in order to make an easier problem for ourselves. Similar to what we were doing on the first page, where I was multiplying my 3 times 4 and then using those zeros because I know that that's what's left over to the end. All right, so let's go ahead and check this out. So we want to figure out 3 times 50, 3 times 500, and 3 times 5,000. So we're going to come down here to our first way. All right. One way to find those three multiplication is to use basic facts and place values. So what does that mean? Well, that means what I'm going to do is I'm going to look at the numbers that are not the zeros. So 3 times 5, and the 5 is not just a 5, it's in the tens place. So we're going to say 3 times 5 in the tens place. So, well, 3 times 5 is 15, and really what we're saying is we want 15 tens. And when that happens, that means that whatever the smallest place value that we have, this number needs to be in our tens place. So what would that look like? Well, I've got my ones, I've got my tens, and I've got my hundreds, right? These are our first three place values. So if I need a 5 in the tens place, and that means the 1 will be to the left, and then that means, well, if this is here, I need a 0 over here. So my answer should be 150. And oh, look at that. Yeah, because the 5 needs to be in my tens place. The 0 goes to the ones to push it over into the correct place value. Let's check it out with our next one. So 3 times 500. Well, this is actually 3 times 5 hundreds, right? And so one other way that I could think about this is I could just do 500 3 times. 500, 1,000, 1,500. That would get me that same answer. That's what we're saying here. 3 times 5 is 15. It's 15 hundreds. So again, I've got my ones, I've got my tens, I've got my hundreds, and then I've got my thousands. All right. So if I need a 15 in the hundreds, that means this smaller place value, this 5, needs to be in that hundreds place. And then the 1 goes in front of it. And then I can't just leave it like that. I have to fill in these place values with zeros. And so, hey, look at that. 1,500, 1,500. Okay. All right. Last one down here is going to be 3 times 5,000. And so I'm going to go through those same steps. So I want you to see if you can tell me real fast. So let me write these out real quick. So we've got our ones, our tens, our hundreds, our thousands, our 10,000s, and then our 100,000s. 100,000s. All right, so I've got my place values here. Let me move that up a little bit more for us. There we go. All right, so just like before, 3 times 5, but it's in the thousands place. 15 thousands, right? Where am I going to put my 5 on my place value chart here? Well, we're in the what place value? Thousands, right? So I need my 5 to go in the thousands place, which means my 1 goes to the left. All my other numbers are going to fill in as 0. So we have 15,000, which was 3 times 5,000, which was 15,000, which is 15,000. They're just different ways for us to write it, but it can help us to see these different types of place values in order for us to do the basic fact and use those place values. Well, another way is going to be using that associative property that we talked about up on the top. Okay, so if I have 3 times 50, these parentheses tell me do that first. So what I actually did was I took 50 and I broke it into 5 times 10. Okay, because what is 5 times 10? 5 times 10 is 50. So we just broke it into 5 times 10. And the reason we do that is then we can shift over and say, well, let's do this part first. 3 times 5, and that's going to give us this 15. And then we have that 10 left over, right? And so that comes into, well, 15 times 10. I've got that 0. I'm just going to put that on the end. Same with when we come down here. 3 times 500 becomes 3 times 5 times 100. 3 times 5 is 15. And then I want to times that by 100, right? 15 times 100 is 1500, which is 1500. It's just a different way of saying it. And then they do that one more time. 5,000 becomes 5 times 1,000. We're just taking that and breaking apart. That's the associative property. It tells us we can do this, and the answer will still remain the same. And you can even double check our answers because we did it 2 different ways here, right? Over here, I did 3 times 5 tens. Over here, I took 3 times 5 and broke it into 3 times 5 times 10. Did we end up with the same answer? Yeah, we sure did, right? So these are just 2 examples of ways that we can go ahead and do this. All right. So let's go ahead and flip over to page 83 and check out what this is going to look like for us over there. So here we are on page 83. I've written it down here for us. But I do want us to look at one more example. All right. Now, this last example is what I was going over on that first page. Okay. On that first page, when we had 3 times 4, 3 times 40, 3 times 400, and 3 times 4,000. The other page that we just did was showing you the why. Why is this? How does this work? This is going to kind of give us the shortcut of what it is that we're talking about and how we can use that shortcut to be able to do these a little bit more efficiently and quickly. All right. So up here it says use place value to calculate 5 times 400 and 6 times 5,000. All right. So what we're really saying here is in these problems that end with 0, right? If we have these zeros at the end of our multiplication problem, what we can really do is just ignore it for a moment and then bring it back around at the end. All right. So what does that mean? Well, that means we could do 5 times 4, and 5 times 4 equals 20. All right. We just focused on the numbers right here that were not zeros. 5 times 4. They're not 0 numbers because the zeros are at the back end. Okay. 5 times 4 is 20. All right. So if I was doing this problem, I would write my 20. And then after doing that, I would go back and say, well, how many zeros do I need to add to this to make sure that the place values line up? And I've got 1, 2 more. And I say 2 more because there's a 0 here, but that's not included in what we need up here. I need to bring these 2 and bring them down. 1, 2. So even though there's 3 zeros here, that's okay because our answer here, the product, was 20. And so now I look and go, it's 2,000. 5 times 400 is 2,000. All right. Same thing over here. I'm going to start off just with those numbers that are not ending in 0. 6 times 5 is 30. Okay. Well, if I've got 30, then I need to say how many of those zeros do I need to bring down from the beginning? 1, 2, 3. 1, 2, 3. My answer is 30,000. Isn't this a little bit more efficient and a little bit quicker than going through all of these steps over here? I hope that you're saying, yeah, this is much quicker, but we need to know on this page why this works for us to be able to use this shortcut when we're doing our practice problems. Okay, so let's go ahead and jump in over here. All right. So I want us to go ahead. We're going to do number 3 together, and then I'm going to give us some chance to try just a couple things on our own. Okay. So we're going to go ahead and start here with 8 times 7. 8 times 7. I got to figure out what is 8 times 7. I don't have any extra zeros here, right? So I just need to know 8 times 7. Well, 8 times 7 is going to be 56. All right, it's 56. Now our next one is 8 times 7D. And if I use the same strategy we just did at the top of this page, I'm going to say I care about this part first. 8 times 7 is 56. And then I'll just ask, how many zeros do I need to bring over? Just 1. So my answer would be 560, right? What about my next one? If we use the same steps, I've got 8 times 7. What number am I going to start with? Try writing it in on your own right now. What am I going to start with? I hope you were like, oh, Mr. Campbell, I get this. It's 56, right? And then I'm going to ask what question? How many zeros need to come over from our original problem? Well, we've got 2. 1, 2. 1, 2. So my answer is 5,600. Oh, okay. I think that we're getting it, right? Next one, 8 times 7 is going to be 56. And then how many zeros do I need to bring over? 1, 2, 3. 1, 2, 3. My answer is 56,000. All right. For number 5, I'm going to ask you to go ahead and solve this one. All right. And I'm going to just talk you through it, but I'm not going to write anything. I want you to do the writing as I talk for number 5. All right. So for number 5, we have 2 times 700. 2 times 700. Well, I'm going to start by saying, what are the numbers that don't end in 0? And multiply those. If you need more time, pause to figure out what those 2 numbers that are not zeros for number 5 are going to be. Next, I'm going to go ahead and say how many zeros do I need to add after my problem. So after I've multiplied the numbers in 2 times 700 that were not zeros, my product goes here, and then I need whatever zeros are left over from over here have to come over and join my product. If you haven't finished, pause, because I'm going to go over it right now, okay? So I want you to try this one, and then we'll go over it. So here we go. We've got 2 times 7. 2 times 7. Well, 7 times 2 is 14. But I'm not done yet because I have these 2 zeros that I also need. So I need 1, 2 zeros. So my answer is 1,400. I hope that you're like, oh, yes, perfect. I got that one. All right. That's what we want to work on. All right. Let's go ahead and check out number 4. All right. Number 4. I'm going to have you pause the video. I want you to solve number 4 all by yourself and then push play, and I'll walk you through how to solve it. If you haven't solved it, pause the video right now because I'm going to go over it. We're going to start with 7 times 7, and 7 times 7 is 49. All right. Because these are not numbers that end in the zeros, right? So now I've got my 0 here. I need to bring 1 0 over. So my answer is 490. Okay. These are the steps that we take to solve these kinds of problems. Now down here at the bottom, when you get started on this on your own, you're going to have some just like what we did up there, where we're going to start with our number and just keep adding zeros. Don't be thrown off that the equal sign is over here. It's the exact same steps. Don't worry. It's okay. The equal sign can be on either side of our equation. It doesn't change it at all. Okay. And then same with over here. We've got 8 times 50 and then adding more zeros. See if you can get these. Okay. Down here, we've got our numbers just like we just practiced up here. They are horizontally, and that's okay because we still just care about the numbers that don't have the zeros. Same with over here. They flip-flopped. It's not 4 times 700. It's 700 times 4. That doesn't change it. We still want to focus on the numbers that are not those zeros and then put the zeros at the end so that our place values will match. All right, 4th grade, that is all that we have got for today. Make sure you are working on your independent practice problems right down here. Have a great rest of the day, and I will see you next time.